Hello, everyone. My name is Ajay Chankramath. I'm one of the co-authors of the new book, Effective Platform Engineering, that is just published by Manning Publications. So together with my co-authors, Nick Chenoweth, Brian Oliver, and Sean Alvarez, I would like to welcome you to this presentation. So what we're going to be talking about today is why platform engineering. So you might be an expert in platform engineering, or you might be new to platform engineering. For everybody, it's always good to sort of take a step back and understand why it is important to learn about platform engineering. So some of the things that we're going to be talking about today is a little bit of the historical perspective of how we actually came about with this concept of platform engineering. Why is that relevant? And how is that going to be impacting your career as well as the evolution of platform engineering as we move ahead? So let's jump right in. So if you look at the state of the industry today, there is significant momentum with respect to platform engineering across the board. So in your work organizations, I'm sure you have certain domains that you actually focus on, right? I mean, you actually build certain products for either banking or your technology side or manufacturing or whatever you're trying to do. So anywhere you have some level of engineering activities happening, you're going to have some value that you can actually get from applying platform engineering principles, and that's sometimes essentially building engineering platforms. But this is not something that we are just seeing in some pockets, right? We are seeing that across the board, 65% of the executives believe that improving that developer experience is the top goals for them in 2025 and going beyond that, which means that in order to improve developer experience, you need to have certain standardized ways of doing it. And that's what platform engineering brings to the table. And this is not just from the point of view of just building the right products, right? It's also about that experience with respect to how developers are able to operate in the most efficient way possible. But it's also a better realization happening within the whole space. Um, I know that we haven't sort of defined platform engineering, which we'll get to in a minute, but just to set the stage here, platforms are important from the point of view of looking at that as products as opposed to an individual set of automation or the activities that you might do in that space. So that's another realization that we see in the industry. And there are sometimes miscommunication and the kind of misunderstanding with respect to whether platform engineering is same as implementing Backstage or developer portals or something like that. I think that realization is getting far better within the overall industry, where most of the leadership believes that combining your developer portal like a Backstage or any of those things plus platform engineering concepts is what people want to do. So as you can see, the trends in the industry are currently extremely high. That is actually, leaning towards building more and more engineering platforms, or more importantly, bringing about those platform engineering concepts. So what are we going to be talking about today? So a few things, right? So one, we'll start with some of the challenges and the past trends that has led to today's platform engineering. Then we'll be talking about how to evolve platform engineering in organizations. And then we talk a little bit about the career paths and the growth opportunities, because as you go through this book that we have written, one of the questions that you might have is that what if I actually become an expert platform engineer? What if I know how to do certain things? Want to make sure that this is practical from the point of view of the career paths and the growth opportunities that you have. But once you build all of that, a bigger question is like, how do you make it all stick? How do you make sure that when you implement platform engineering, this is not something like a passing fad? So we'll talk about how to actually make sure that it all sticks. Then we'll spend a few minutes talking about the current and the future trends in platform engineering. And I'll conclude by talking about how does this book sort of help you in doing that. So essentially, we want to talk about what led to the platform engineering of today. For those of us who have been actually in the industry for a while, who have done a lot of these activities with respect to developing products, developing software products, and things like that, we know that typically a product development activity, evolves around, having the right architecture, making sure that you have the right process. Then you are trying to ensure that there is an operational rigor to that. and then of course build in the right kind of security upfront as opposed to being an afterthought, and eventually making sure that you can measure all of that, right? So if you look at that evolutionary cycle, these are probably those 5 steps that we see as the critical aspects of how do you actually develop the product. So what we're going to do now is to go through each of these 5 elements and really try and see where we used to be and where we're going with that, and where does that platform engineering fits in across all of these. So from an architectural milestones point of view, I mean, we know that people have been talking about, loosely coupled with high cohesive architectures as the key aspects to building software. And this is not something that just came about when we started talking about microservices, 10 years or so back, right? This has been around from the advent of time, I would say. Probably, some of the first books that I've seen around this has been in the late 60s, and there have been like some seminal work coming up in 1970s, where people have been talking about, hey, this is the right way to do things. So as you really started looking at that, you find that there are aspects around it that we have been struggling as an industry to do it right. And then as you really started learning more and more of those challenges, we are trying to come up with the right kind of solutions around it. So what are these solutions? So I'm sure in the mid 80s, early to mid 80s and all that, you started talking about things like client server aspects, right? I mean, so you're trying to make sure that you have your higher workload sort of done at your server side, and making sure that more of those user interface or the user interactions happen, and the commands to actually get the applications to do what it needs to do from a client side of things. Then came about this whole idea of middleware. I think we started talking a lot about middleware. It was late 80s, early 90s, and all that. Where it became so important so that when the number of applications were in abundance, we wanted to find a way to make sure that they all talk to each other in a more effective way. So unlike in the typical client server world, which is more of that methodology, in this middleware idea, what we ended up doing was that we could really try and see how do we get the multiple systems to sort of work together. Then came about into the 90s, late 90s, and all that came about this idea of virtualization, right? This sort of democratized the whole process of developing products, software products, because you are no longer being constrained by the kind of hardware that you have, and whether the hardware could work. If you could just start virtualizing that hardware, the whole process became far more easier. Then came about this idea of SaaS, right? Essentially, if you are not able to actually have your software be installed at some place, could you actually install it like within your servers, within your ecosystem, and have people sort of start using that? So with the advent of network, the advancement in networking and the internet, you really started finding that, yeah, I mean, having those SaaS products became far more viable. I remember some of the first SaaS software that I built was around 2000, 1999, 2000 time frame, where we really started taking advantage of some of the highly compute intensive activities within the semiconductor space. Be handled at the back end, at the server side, and that the application developers or the designers sort of interact with the system through the kind of networking capabilities that we had. Then fast forward a while, we actually found that significant amount of container orchestration related activities became a huge part of how we develop software, which is what we are doing today too, right? This provided significant benefits across the board. Things like, you're going to have significant amount of higher availability, and, your resource utilization and efficiency became faster. And most importantly, you could really have a guaranteed way of making things work, because in the old days, we used to always talk about ideas like, hey, it worked on my machine, why isn't it working somewhere else? So some of those problems were easily addressed by using container orchestration. So a lot of these architectural milestones really told us that, yeah, there are problems that we initially found, and we sort of evolved over time to actually have to solve these problems. And these problems required an underlying consistent and standardized way of solving it. And those things really led to the idea of platform engineering. From a process milestones point of view, also need to think about from the point of view of agile manifestos. It sort of came about in 2001. Now that's, and so the idea being, as you really started looking at the process of building software, it became important that having a consistent way of building the software and ensuring that the value that is realized by the product or your software started showing up faster than having to wait for a long time became a huge thing. Nowadays, I know that there is a lot of conversations regarding whether agile is the right thing to do or not. Uh, that may or may not be the case, but one thing that can't be debated is that customers eventually seek value faster, right? Your end users need to see the value faster than having to wait around for a long time. And to me, that is that process milestone that really held, the movement towards having more impactful platform engineering or the engineering platforms that can actually drive these things. Another thing that happened about 20 plus years back was Google came out with this idea of site reliability engineering, where you really started applying some of the key software engineering principles to the operation side of things. So this was, again, a seminal work that actually changed the industry as a whole, because the idea was that until then you need to have like an operations team that actually do the operational activities based on all the tools and the software and everything that is written by software teams. That concepts got turned on its head and really started bringing about significant amounts of positive impacts on how to actually create consistent tooling and systems and ecosystems as a whole that would impact the whole software development lifecycle. And you also started seeing significant challenges around tool proliferation, right? I mean, at least the past 15 years or so, you're seeing that there are so many tools. If you really look at that life cycle of your DevOps life cycle, you see that across every step, there are so many different tools. So organizations started having a lot of different types of tools that actually were in the organization, being used by different teams within the organization. But what made matters even more interesting was that it's not like one tool for one activity. So if you're doing a monitoring and observability and those kinds of things today, I'm sure most organizations have multiple tools within that. Similarly, you have, if you really look at across every step of the DevOps lifecycle of plan, build, doing your continuous integration, and the kind of deployments and create the operation, and all that. You see that across every step there are multiple tools and tool sets available. So it became so much more difficult for the organizations to sort of keep that consistency and standardization around. This was around the time in which, we have started seeing a lot of different works, like thoughtful work that has been going into it. A few of them I would love to call out are, things like the Accelerate book. We have Nicole and Jess and Gene Kim really started, putting that baselines out there that says, hey, here is how you should measure your success within your software development lifecycle. And if you actually do that, if you measure and if you actually set certain kind of KPIs for your development, you are actually going to get an organizational benefit out of it. So this is, the idea was that your business success is definitely tied to how you actually, the kind of measurements that you actually have on your on your development. So until then, it was known, but there was no scientific research and data that actually supported that. It became far more easier. Then the huge work around the Phoenix project, as you all know, how did actually, people really, how did organizations start seeing some of these problems initially, and once they start seeing the problems, how did they actually solve it? And so this was presented as a story, so it resonated a lot with everybody in the industry. And as we moved along, we had also this book around this DevOps handbook, which was like, to me, still in the Bible that actually talks about lots of concepts that we have been using and put in a more structured way, kind of thing. And then the recent years, the work by Matthew Skelton and Anil Pace on the team topologies really started breaking this down beyond a technology problem and a process problem into a people problem too, right? Because when we talk about people, process, technology, there is a reason why we say it that way, because people problems are the number one challenge in really getting your products built the right way and used the right way, and then the process related things, and then became the technology, because technology became an easier part compared to the other two. So This team topology is work that essentially talks about how to actually set up your organizations in a way that is most effective for you to sort of adopt your, the kind of process that you have became very important. But also, historically, we know that there are certain challenges with respect to the operational milestones, right? So essentially, what I mean is when I started building software the first time, maybe in the late 80s, early 90s, we started seeing that things like spec benchmarking and those kinds of things came about. This talked about like what are the kind of things that you should be measuring when you're building the right software, right? And some of the earliest software I built as so this essentially was we were all using Unix, this predated Linux, and we're using Unix platforms. And once you actually do all of those, once you build your software, now what we found that most of our customers used to be on like Windows because Windows 3.1 and all those things were starting to come out in the early 90s. So the portability was not that easy during those days. So we started really working on a lot of the portable aspects of things. Then once you build the software, this was pre-agile, mind you, and this is where you would have a release cycle that is of 18 to 24 months. When you're trying to do things like that, what you find is that you actually create your software and all that, and then put it on a media and deliver it to your customers. Literally ship it to the customers. They would have to actually get the software and then install it. Install it using some kind of installation tools like Install Shield and all that, and then they might run into issues. So essentially, that whole friction was happening across each of these steps, as you can see. Then software integration also to me is a huge part of that operational milestone, right? When you really started talking about what are the real types of, how do you actually make sure that when you have hundreds of developers developing your product, how do you integrate all those things and make it work together in a timely manner? So the early CI/CD systems also became, very interesting. And as we actually moved along, we found that, having that continuous integration, continuous delivery, and the continuous deployment aspects became far more interesting and valuable. There aren't still a lot of organizations do true continuous deployment compared to some people using CI and CD in a continuous delivery. But at the same time, understanding that and ensuring that your NFRs are as much as possible built into your CI/CD and ensuring that those things are happening consistently for everybody who's building the software, make sure that your overall, not only your overall software development became efficient, but your process of delivering and ensuring that the people can use it became far more efficient. And the other thing I want to talk was about the security milestone side of things. These are things that are very well known. Over the years, you have seen significant challenges with respect to some of the breaches as well as the compliance and the standards that have come out of various parts of the world. And these things have been a huge challenge for organizations to ensure, mainly because educating every developer of all these challenges and how to actually go about fixing those things wasn't an easy task, right? So you wanted to build the right kind of process so that this process can actually help the whole idea of developing the software. So this is where that whole idea of including these capabilities as part of your engineering platforms, making sure that you build in the right kind of gating and ensuring that people can actually use the engineering platforms or the capabilities that'll provide these requirements right out of the box became far more. Hello, everyone. If you're finding this presentation insightful, I highly recommend that you check out our full Effective Platform Engineering book published by Manning Publications. This was authored by Nick Chenoweth, Brian Oliver, Sean Alvarez, and me, Ajay Chankramath. So the deck you're seeing is just tip of the iceberg. This book walks you through proven frameworks from how to build internal developer platforms to actually getting that adopted and mapping the value across platform lifecycles. You'll also get deep insights into how real-world organizations are handling common blockers, like scaling DevOps practices, balancing that buy versus build thing that we've been talking about, and driving developer experience through observability and compliance. There are interactive exercises, team topology models, and hands-on patterns that you can start using right away. So the link is in the description, along with the limited time discount code. Grab your copy today and bring platform thinking to life in your organization. Thank you. Far more prevalent. So once you do all of that, the question really becomes like, yeah, I'm doing all of these things, but how does it matter, right? Am I improving anything? So one thing that we have seen in some of the, like even in 2023 State of the DevOps report, this is obviously improving as we speak, is that over 50% of the organizations, developers only spend about 30 to 40% of their time doing feature development. So if you think about it, this is such a disaster, right? Because for most organizations, the single biggest expense are the people. I mean, and when you have that much people who are that many people who are actually less productive because you hire them to actually build the right products, and if you can actually get only 30 to 40% of their time to do feature development, what it really means is that you are essentially paying a tax, 2x tax for every developer that you are actually hiring and having them do it. So this is where the whole idea of developer experience became far more important, where you have to really start thinking about how am I actually going to take these developers and make them more productive. So as you really start thinking about this, right? I mean, so what are the real causes of bad days for developers? So last year, Microsoft did some research around this, and one of the things that they found was that like engineering system friction was the single biggest reason. And you can see a lot of things going down the list, right? A lot of reasons that you might actually resonate with you, but all of those things are really telling you that there are ways in which we can improve the experience of the developers and making them more focused and getting them to do the right things so that they are far more productive than 30 to 40% of their time doing the actual product development. So this is the core of platform engineering. So by building engineering platforms that are specifically solving the problems that developers have, not a standard set of problems, not like building an ideal platform that somebody can actually say that, hey, if you use this, you'll get better. It goes the other way around. Talk about it from the point of view of what are the specific issues for your developers and how do we actually provide a way to make them be more productive by solving those problems. So that's what essentially this data is telling you. So focusing on developer experience also has both this qualitative and quantitative metrics, right? And essentially, if you're looking at developer experience, in the early days, people are talking a lot more about DORA and DORA and space metrics are all supremely important even today. But at the same time, there is another component, the qualitative metrics, that has become far more interesting these days, right? So because you know that just by measuring what is happening, within the system automatically, it does not always tell you the full story. The whole story is told when you're really looking at what are the sentiments of the developers, right? So, for example, if your system is saying that, hey, in order for me to go from step A to step B within my overall DevOps life cycle is X number of hours, sometimes that hours or the days or the minutes or whatever that you have isn't telling the story of how a developer would feel about this. So we started really coming up with a lot of those ideas around qualitative metrics that started telling you the whole story. So now we talked about a lot of different concepts already, right? We talked about developer experience, we talked about DevOps, we talked about SRE, and talked about platform engineering. So if you are getting a little bit confused, I understand. So let's actually try and sort of define these things before we get to the next step. So to me, developer experience is that experience that developers have when they interact with the tools, frameworks, processes, and all those things through SDLC, right? So this is what we talked about DevX being both qualitative and quantitative. So it's that overall experience we are talking about. So this requires platform engineering because this is where an engineering platform can start helping the developers become more productive. Now, if you really look at DevOps, there's always this misuse of the term DevOps as DevOps teams and DevOps engineer and all that. But it's mostly a cultural paradigm, right? So it's a cultural paradigm that sort of improves your overall collaboration communication. So recently I saw something on LinkedIn when somebody says that they asked this question, what is DevOps for you? And somebody said, oh, Kubernetes is DevOps for me, right? So Kubernetes is not DevOps, tools are not DevOps. It's essentially that collaboration and communication between all aspects of development lifecycle. So DevOps is enabled by platform engineering because in order for you to enable that collaboration communication, you need to have the right kind of the engineering platform do that for you. Then let's talk about SRE, right? So we talked about SRE already as this applying software engineering principles to operations for creating highly reliable production systems. So as you do that, platform engineering sort of supports it. So just like it provides the kind of enablement of the DevOps activities, it also supports the SRE, right? So essentially think of it like that core platform engineering is the core that sits between all of these that ensures that you are getting the best solution as you are really trying to solve your overall challenges within product development lifecycle. So if we were to sort of define this, so a definition that we would give it to platform engineering is that it sort of enables DevOps while supporting site reliability engineering and including observability and all that. And it's required by DevX as a product because essentially it's important to, as we spoke about earlier, important to look at platform engineering as something that is created as a product as opposed to more of a set of automation or scripts or like processes we have. And by using theory of constraints so that you get the right kind of priorities along the way. So this is something that we talk about a little bit. We go into some version of this within the book, but this is another view that we wanted to share with you. Sometimes it's easy to get carried away with terms like an engineering platform and saying like, what does it contain and things like that. So it's always important to scope these things the right way so that you don't end up creating a set of requirements that keeps increasing every day. So one way we would want to look at this is like look at this across 5 different horizontal planes. So these are all self-explanatory. I would let you and look through that for a second. So as you can see, things like security plane at the bottom is one of the key aspects of how you do this, but also the networking and connectivity plane. And then you have your delivery and runtime plane, which is what is mostly considered as the engineering part of engineering platform. How do you actually do your Kubernetes? How do you containerize and things like that? Overall workflow orchestration. But you also have that compliance and governance plane sort of built into it. So is the developer plane, right? I mean, so this is where you're really doing a lot more, for example, with the advent of more of the AI tools and the code generation, things like that. A lot of those things actually go into developer plane. Even the vibe coding and all the things that we talk about today should go into that space. But the interesting thing here are those vertical planes that you see there. So the platform product management is extremely important, and that's what really the primary difference between an older way of doing things versus a newer way of doing things, because you're really looking at everything that you're doing in the context of a product as opposed to essentially a set of toolkits, or the scripts, or the programs, or whatever that you build there. Together with that, on the other side, you can also see the observability, because this is extremely important for people to really change the way in which people think, right? I mean, so historically, observability has always been like, let me look at my infrastructure observability and try and see if I can fix that before my clients see it. Also, it could obviously be on the application side of things. But one of the things that platform engineering can bring to the table is that you can actually have a view of observability that is far beyond just your applications and infrastructure. It becomes that end-to-end view that you can bring into your ecosystem that talks about how does my observability fit in when it comes to my cloud services, the tickets that are being, the problems that my users are seeing, any of the other additional services that you have. Or eventually, how does that fit into my overall business process? If I have a problem with an infrastructure in one end, how is that really impacting the overall business process? In some cases, it may not. Some cases, it would. And knowing that ahead of time would let you fix these problems better. So the other idea that you should be thinking about is what are these themes within the engineering platform area, right? So first idea we spoke about a little bit is to essentially measure waste and friction. So if you cannot measure waste and friction, you're really not going to be focusing on the right things. The second thing is always about strengthening that technical product thinking. We spoke about that a little bit. This is not just about automating something or creating a new tool. It's about like, can you actually do that as a product? Why? Because if you do that as a product, it'll get the right kind of rigor to actually have a life cycle. And the typical product life cycles have the right kind of requirements collection. You're building a product for somebody who needs certain things, so you ensure that you understand those things from your developers upfront before you go into building things. And even when you're building it, you're prioritizing based on value. And I think that's going to be a huge aspect of it. And once you prioritize based on value, you're going to have multiple versions of it. So you're going to actually come up with iterative ways of improving that product. And that is exactly the way you should be looking at an engineering platform. And then in a favor, you buy in buy versus build, decision, right? This is a common mistake most organizations make because it's almost always within your organization far more difficult to justify buying a new tool and buying licensing for a new tool compared to going and doing some skunkworks projects or getting a couple of people or one person to go in and build certain things. You yourself might be tempted to go build certain things because you're seeing that, hey, I have the ability. I know how to do it. As engineers, we all feel like we have the ability and the skills to do everything. So let me just go build it because that's easy to do. But what is missing when you're thinking along those lines is that you tend to actually create a higher total cost of ownership. So what you want to always do is that reduce that TCO by favoring buy in the build versus buy decisions. I'm not saying this is true in 100% of the cases. I'm sure there are in some cases, you might actually find that building something is better, mainly because, the product or whatever you're buying gives you so much of this capacity and so much of the capabilities, but you don't really need that, right? You might need only one or two capabilities out of it. So is it better for you to build? Maybe, right? So that is something that you have to really think about it and ensure that you always build value on top of what's available as opposed to try and reinvent the wheel. If you try and reinvent the wheel, more often than not, you will actually lose, right? Because somebody else somewhere has more specialized skill sets within that space and they would actually do that job better. So over time, you end up creating higher total cost of ownership. The other principle there is, of course, from the point of view of can you have a more composable, extensible, replaceable ways of doing it? One of the key platform principles, right? And this is closely related to the previous one we were talking about the buy versus build. So when you're really trying to buy certain products or have certain different components, that is the best solution for a problem today. What if that solution gets changed, where somebody else comes up with a better solution tomorrow, right? How easy it is for you to actually not get locked into a vendor or a license or something like that. It is important for you to really do four if you're doing three, or should do both three and four, right? Because if you don't have a way of replacing some of those options easily, you're going to have a challenge where you might be stuck in with a particular license for a long time, and that'll create more inefficiencies. So we already spoke about that end-to-end lifecycle observability. So idea here is that observability has to be not just application or infrastructure observability, it has to be an end-to-end lifecycle observability. When we talked about the team topologies book, we talked a little bit about how do we actually ensure that different components of your organization with your platform approach can be autonomous, right? I mean, so it is important for you to really make sure that every team is as autonomous as possible, meaning like they are self-sufficient. This is just not the question of creating that self-sufficiency within your engineering platform, but also from an organizational point of view. Who are the people that they interact with, and can they make the decisions themselves? How do you empower the teams to be more, like autonomous to be able to make the right kind of decisions that they should be making? So that is the key principle in there. The last one is probably the most important, that drives everything, which says that don't do something if it is not, some generating value. When you talk about value, it's not just about defined value, but whether you are articulating that value, saying that, hey, I define this, and people can understand that, then being able to measure that, right? So this goes back to that first one. This is why it's shown in a circle, goes back to the first one, whether you can measure that, right? So if you are building something within an engineering platform space, you should never do it again, or any kind of platform, even if it's not a specifically engineering platform, in any kind of platform related activities, you should not be doing it if it is not generating that value that you think should be generating. And these values today can be measured fairly in a very objective manner. And we'll show you a couple of ways in which you can do it. That quantitative value that measured and then an objective measurement of it is extremely important as you make these decisions. So with that said, let's really look at what our practitioners are saying. So again, this is from last year's the State of Platform Engineering report that came out I think in 2024, sometime mid 2024. So the reason why developers are finding platform engineering useful is because of that. It provides that significant increase in productivity. And they obviously in the survey, developers were asked to select more than one, so it's not just confined to one. So you can see that everything that follows the increased productivity are things like better quality of software, better lead time for development. Can I get better applications themselves, and can I allow the developers to do multiple things at the same time in a more efficient way? There's so many different benefits that you can see as you apply some of the principles that we spoke about in the previous slide, as well as bringing in a engineering platform approach to doing things. Hey, it's me again. If you are nodding your head, learning something new, or already thinking of how this applies in your team, hit that like button. And if you know a colleague who's trying to figure out things like how to manage compliance at scale, reduce friction in CI/CD, or introduce internal platforms in legacy-heavy organizations, share this video with them. These topics are becoming critical across industry. Your share might just help someone finally crack that developer experience code or avoid reinventing the wheel. Every like and share helps keep this channel going and make it possible for us to keep sharing practical in the field knowledge. Appreciate your support. Hello there. We are moving fast, so if you have got any questions, don't hold back. Curious about how to implement observability across platform layers, or how to define platform value in a way that resonates with your leadership team? Maybe something like we mentioned, like the compliance at the point of change, or sparked a thought. Drop your questions in the comments. I go through everyone, and I would love to answer, go deeper, and even build a follow-up demo based on your feedback. The space is about learning and evolving together, so let's keep the dialogue open. Now, let's really talk about how do we evolve platform engineering in organizations. This is something that, and I've gotten a question in various conversations that I've had. This is where people know that, hey, now I understand platform engineering. Now I know why platform engineering is needed. I even know what I might have to do to actually to build an engineering platform. But how to evolve that within organizations? So if you really look at how why platform engineering emerged, the drivers were, as we spoke about, that historical perspective, like the complexity of the modern stacks and some of the developer productivity concerned, combined with ability to scale your DevOps practices, right? So you had what we call as this DevOps lifecycle, and all these practices were there. It worked great for a couple of teams, a couple of people, a couple of teams, and all that. Then as you started, organization started growing, your number of product complexity started increasing, scaling became a challenge. And then the demand for standardization sort of started kicking in. So with those drivers, the whole genesis was like, okay, could we actually self-identify the pain points? If we know what the problems are, do we know exactly what it is? This is where ideas like value stream mapping and all those things started telling me that, okay, here are the real pain points within that. Then together with that, we started seeing this idea of grassroots efforts, right? Because people were really starting to build things. So if as an engineer, I have a problem, what I typically do is I'll go and try and fix that, right? So I'm sure you all like that. So those efforts were a huge part of how platform engineering sort of started coming together. Then executives started seeing that, hey, you guys are actually doing some nice automation. So your managers saw what you're doing, and they started talking to the executives. They figured out, okay, this is a great effort. We should sponsor that. So, okay, that was another genesis within that. So together with that came, okay, once we did all of those things, people said, okay, executives said, you guys seems to be adding value. Let me actually create a platform team and have them, provide the whole organization a minimum viable product that can actually get into solving the class of problems they have for my whole organization. So this is how the whole platform engineering teams and platform engineering itself evolved. But the problem with all of those things was like, when you started doing certain things, like, doing grassroots efforts and all that kind of stuff, people started over engineering, right? Because you're not really collecting the requirements and you're saying, I'm not building things for the requirements. I'm building things for what I think are the problems. Now, so that doesn't mean that it's not solving any problems, but it solved a lot more than you really needed to solve. This also led to lack of developer buy-in because when you're creating something fancy and cool and things like that as a developer, as an engineer, engineers tend to over-engineer things. So and you started doing that and then giving to the developers saying, hey, you should use this tool, your life would be better. They started playing around with it and they found that, you know what, might be great, but I don't have time to learn all of that. That cognitive load still became very high, right? There's also the cultural resistance of things, right? Because as we talk about people process technology, the biggest challenge within that whole space is how people understand the problems need to be consistent. If it's not consistent, then there is no collaboration, there is no real DevOps happening. So eventually it all led to that misaligned priorities within that space. So what we find is that an ideal platform engineering journey for organizations really starts with the idea of not just building tools, but it's about building trust, right? If the developers don't see the value in a platform, how much ever brilliant the platform is, it's not really going to cut it. So one of the things quotes I always use is one from Eric Ries in the Lean Startup book, right? I mean, so essentially starting small, deliver value quickly, and iterate. So this is where you can really stop having that over-engineering problem there or the lack of developer feedback there. So getting something, built as a product sooner than later, and with only like one capability, ensuring that that is understood by the developers, let them give you the feedback, and as you really start building in the feedback, have that iterative improvements there and create a mature platform. So to me, this is sort of the ideal platform engineering journey the organization should have. But it's also good to take a look at, right? This is more based on some of the things that we see in the industry, like what are those patterns that you see within platform engineering? So essentially, like if you are to build this team, could it be a grassroots one? Could it be management driven? Could be any of these things? So as we have looked through this, there are at least 6 different patterns that you would see that are really going to tell you like who should be doing the work within the space, how is it done, how is it evolving, and what are the kind of examples that you see. So you can see that beyond grassroots and the management driven, not meaning like a bottom up or a top down, more of that successful ones that we have seen are mostly on that hybrid side of things, right? So essentially we combine both of those things because then your engineering teams as well as your executives are mostly aligned on what is needed and how to actually go about doing that. We have also seen, and as we have seen from some very famous, case studies, crisis-driven ways of doing platform engineering is also very popular, right? Because when you have some major instance, then you're going to say, okay, this cannot happen anymore because it has cost the business millions of dollars. So I need to go fix that, or we need to go fix that. So board comes in there, and everybody says, okay, here is how we would actually go do that. And this has also worked, but again, this is something that would require a lot more of that people coming together, meaning the engineers coming together and having the clearer mindset, because a lot of these crisis-driven things tend to be a combination of the leadership as well as the engineering one, like the hybrid one, but it ends up being more of that top-down activity. There are times in which you find that a unicorn vendor product can actually drive certain things, right? I mean, so one of the movements like that I've seen is things like Backstage, right? I mean, so Backstage is a fantastic product from a point of view of developer portal. But people tend to believe sometimes part of it is marketing, part of it is misunderstanding within the industry. Like a backstage is my solution to my engineering platform problem. It is not, right? So when they say that, okay, let me actually build a backstage and that solves my engineering platform problem, that is probably the wrong way to do it. But there are other unicorn vendor products too that you might find that that's unique enough that it is actually creating a revolution there. Then places like Target, one of the things that we have seen is that some of the existing DevOps teams sort of understand what is happening in the industry, and these DevOps teams have morphed into this newer ways of doing things. And again, how the processes going from that automation heavy aspects to more reusability and self-serve ways of doing it. So as you can see, some of these patterns are very powerful. So you might have to really think about what is that pattern that works for you in your organization. And if you don't have one, pick one. And definitely don't pick the one that is crisis driven, but pick any of the other ones. Make sure that you are actually set up to be successful here. So the other major question that we have is like, what's the right size of an organization before they actually adopt an engineering platform, right? So the idea is uh, if you are way too small, if you don't have scale, or if you don't have a scaling problem today, it's probably not something that you should worry too much about. But if you don't have scaling problem, there is a high likelihood, in most cases, it's not 100% of the cases, most cases you will have a scaling problem tomorrow. So you should be thinking about it and planning ahead. So the way we would think about it is that look at this approach for when should you have engineering problems across these 6 different axes. Number one is value. Look at it from the value point of view, things we spoke about, right? What are the pain points? How do we prioritize value? Can we create an MVP? This ensures that you don't end up spending so much resources, which is where you get the biggest pushback. But then look at it from an automation point of view. What are you automating? Why should you be automating that? Should it be just your IAC or CI/CD? And could you make it more self-serve, right? Security is something that is a great place for you to really start, because that is, it gets more important every passing day. And as you really look through it, ensuring that you have that security built into the pipeline and have the automation for it makes a whole lot of difference. The recent past, there have been a lot more conversations around cost, whether it is, and it may, especially when you have started using a lot more of the cloud on the public cloud resources. Am I tagging my resources correctly? Am I actually ensuring that my development itself is more cost aware? Those are all significant considerations that you should have. Then collaboration, right? I mean, so this is where you're really starting to see a lot more teams working together now with significant usage of Cursor and Cloud Sonnet and all that kind of thing. So a lot of automatic code generation with the Copilot tools happening there. This is becoming a lot more of the issues. Now the collaboration is not just between humans and humans or human teams. You also have collaboration that is happening where developers are becoming a lot more of those prompt engineers with generating code, right? Recently, I read some statistics somewhere saying that 50% of the code generated in 2025 is going to be AI generated, and maybe by 2027, pretty much 100% of the code will be AI generated. Is that true? I don't know, right? I mean, there are signals that are saying that the significant part of the code that is going to be generated automatically. But when you have that, the collaboration takes a whole new meaning. The the last axis that you should be looking at is from a tools point of view, right? So when I say that, what I'm thinking of is like, are you able to adopt more open source tools? And if so, how do you actually do that? Can you actually do that? And then you are tempted more and more to use more of those cloud native platforms. And then that sort of leads into more of those platform engineering tools that are far more mature than it would otherwise be. So for hybrid organizations, so these are organizations, when I say hybrid, what I mean is organizations that are in cloud as well as on-prem. Even if you are a fully cloud native organization today, there is high likelihood that you might actually go back the other way, and you might have a truly hybrid organization in the future. So we expect most of these organizations going forward should have some level of cloud and on-prem workloads. So as you look through that, a few things to think about is that what are the challenges there? So the challenges there would be more along the lines of, am I going to have my connectivity and integrations issues? Could there be more heterogeneous environments and all that? So as you really look through all of those challenges, you need to come up with strategies for each of those things, right? And these strategies would all be an excellent use case for having it driven through a engineering platform. And once you build these capabilities or once you address some of these strategies through those engineering platforms, you start seeing the success factors are things that can be measured. So this is where you have to think about, if you are doing something, are you getting the right kind of executive sponsorship? Is there like a right kind of cross-functional collaboration happening, or is there like clear communication? So I think establishing those metrics as to what your success is going to be and doing it at that level is going to be the right approach for hybrid organizations. So I thought it would be also interesting for you to just take a quick look at platform engineering careers. If you are like somebody who has been a platform engineer for a while, a practicing platform engineer, you probably might want to skip this session. But essentially, here what I want to talk about is how is the industry sort of adopting this platform engineering as a career for people who have been doing DevOps work or any of the other software productivity and development work over the years. So to start with, what we did was did some scientific search across popular job platforms and things like that, and you can see that the number of platform engineers platform engineers needed by the industry is still a little bit lower than you typically would find a DevOps engineer or an SRE. And this is drastically changing. This is and especially on the entry level side of things, you're seeing that there is a lot more platform engineers needed. And as you actually move to the other end of the spectrum, you find that the executive levels of platform engineering jobs are actually increasing drastically. So the rate of increase of some of these things, ever since I started tracking these things, you see that there's a significant increase there. So all this to say that for now, none of these jobs are going to go away, right? I mean, SRE jobs would be SRE jobs, and DevOps jobs would sort of remain that way, but at the same time, it'll sort of move into a lot more of the platform engineering jobs. Hopefully not by just changing the title of the job itself, but at least by changing the functions. And we'll talk about what those things are. So, but it's important to see that platform engineering is a true viable career that you see today. From a skill sets comparison, it might be easy for you to look at. It's a highly simplistic view of it, I agree. But if you look at it from the point of view of what is a platform engineer versus a DevOps engineer and SRE, a way to think about it is that platform engineers build the capabilities. DevOps engineers sort of uses the capabilities. So if both platform engineering and DevOps engineers are available in the same organization, sometimes if they are not, more likelihood that there's some DevOps engineers historically. If that's the case, they are the people who are building some automation, probably not as a platform, as a product, because if they're already doing it, then they're already a platform engineering team. But then the SREs are the people who actually use this to scale, use those capabilities to scale and understand the problems directly from the client at that level. So you can see that level of the kind of impact that each of these teams, each of these personas would have within an organization. And salary progression is another interesting thing that you would actually find, because as we have been really looking at this data, what we are seeing is that the salaries of the platform engineers tend to be much higher than a DevOps engineer or an SRE engineer. And this is significant if you think about it, because as you know, SREs have been one of the real good SREs are some of the highest paid engineers within an organization. So what we are really seeing is that platform engineering is not just catching up, but especially when the experience increases, you find that the number of or the salary the average salary that you would get or you would command as a platform engineer is going to be far higher. The skill sets also within the space has been evolving. So in 2010, Probably we didn't used to call anybody platform engineer in 2015, definitely so. I myself used to have a platform engineering team around that time. So we are seeing that the kind of skill sets that's needed for a typical platform engineering itself is evolving. So as you can see that today in 2025, what we are really talking about is agentic AI and making sure that platform engineers can actually create those autonomous agents, or autonomous multi-agents that can actually solve a lot of problems that you might otherwise want engineers to actually use as a capability and solve it. And these things are evolving as we speak, right? So while it's so difficult to predict the future, as you look at like the 5 years, obviously some quantum computing awareness is going to be critical, but even things like more of that edge computing management and some of those advanced AI driven operations are going to be part of it, because whether we like it or not, there is definitely a movement towards less of the developers writing the code and ensuring that more of these autonomous agents doing the job, or like code generation tools doing it. As you do that, the role of platform engineers itself would actually not go away, but it will actually evolve into something that actually brings the collaboration between the humans and the AI at that level. So there is significant changes that you can expect over the next few years within the platform engineering space. But the whole concept and the idea and the value an engineering platform can build to the table, can bring to the table, is only going to increase over time. So we talked about a few things so far, right? So we talked about how to launch a platform engineering team. What are the skill sets that you should have in your team? How should you actually make sure that these capabilities are available within your organization? What are the principles that you should have around an engineering platform? But assuming that you did all of that, you brought platform engineering to your organization. Now the question is like, how do you make it stick, right? It's easy to start anything, but sustaining something is far more difficult, right? So the first thing is that as you sell PE in your organization, right, the first thing you should be thinking about is like, can I really identify a real problem I'm trying to solve? Nobody's going to buy platform engineering into your organization just because you say it's a great concept if they understand it's a great concept, right? It has to be you're trying to solve a real problem. As you're trying to solve that real problem, are you able to articulate the objective value within that? If you are able to do that, the question becomes like, can you make a case for investment? And the investment, is always great. So, but people would always ask for my ROI, right? So the question is like, how soon can I actually get to that point where I can break even? So this is why the concept of MVPs are so important, right? So you need to make sure that, yeah, I can actually show the value. If you invest X amount of dollars, I can give you like 2x the return within a month or 2 months. That is a far more compelling argument. And then ensuring that the product management is in the loop. When I say product management, what I'm talking about is not the platform product management or your domain product management. Essentially, ensuring that the domain product management. What you really mean by that is when you really ask certain capabilities to be done. Product managers should have to think about it from the point of view of, oh, if my developers don't have to worry about certain things, that is actually a great thing for them, because then they are actually going to get higher bandwidth from their actual domain product developers to be able to do more of the work that they need to do. So that sometimes is missed within an organization as you really start selling it, but ensure that that happens. After you sell becomes a more interesting thing, as we spoke about. So let's say you build some things that some of your pilot users wanted, not something what you thought was the right thing, but what your pilot users wanted. This is where technical product management would come in. You also need to make sure that you don't build what you can buy, right? So you should, I would say never, but at the same time, look at it from the case by case basis. Make sure that you can buy as much as possible if you can, and demonstrate that quick value. So these days, when I say buy, you don't even have to go buy something. You can always try an open source version of it or some kind of a freemium version, and then build off of that. And once you show the quick value using MVP, you scale only if you need to, right? Because not every investment. So, for example, if you are working in a startup or like a mid-sized company, and your current goal is to scale to the level in which an engineering platform can handle things at 20 million customers in 5 years' time, don't build your platform to support 20 million customers today, right? Build your platform to support the scale that your business needs. So we have some models that we'd love for you to check out. We published this last year, so take a look at this model that talks about how to actually measure your value as you're building some of these platform capabilities. And there are several other models that's out there, or you can actually go build it yourself. But this is one of the models that we have seen organizations use fairly effectively. So so let's say, yeah, you actually sold the concept of engineering platform, and your team started using it. But the challenge continues to be like, how do you ensure that there is higher level of adoption? So this is true with any kind of new tools or platforms out there, because one of the more recent conversations I'm having is that a lot of the organizations I talk to tend to use Copilot. So they say that we brought in Copilot, but the actual adoption of Copilot capabilities seems to be like low. It's not increasing beyond a certain point. It's plateauing out pretty soon. So as you really look at the adoption of an engineering platform, the capabilities within your engineering platform is not that different, right? You have to look at it from the point of view of what's the value that is bringing to the developers. And then you'd also have to look at from a system point of view, what are the kind of systemic value that it can bring in. And eventually it goes down to neither of your developer value or system value, it goes down to your organizational value. Because even if you convince your developers of the value and they start using it, they're going, when the push comes to shove, they are actually forced to make a decision for the betterment of the organization. To say that, okay, I don't see the metrics, I don't see the value at the level in which the executives might say, don't see the value at the level in which I would like to see, which means that you have to go do things the old ways again, right? So ensuring that you look at these value prop across all these different axes and making the decisions along those lines would be very, very important. So again, I'm sure you all have seen this if you have read Team Topology's book, but this is where it becomes very interesting to see, like, you should know where your platform team resides in the context of larger stream-aligned teams, which are your product teams, or the enablement team that ensures that the stream-aligned teams can use your platform capabilities, or the complicated process team, which would ensure that very specific, specialized capabilities are built, right? So ensuring that there is this collaboration happening and in a right structure is very important. There are a lot of research happening within this space. I would urge you to check out teamtopologies.com, and there's like a lot of different models that they are coming out with, and that is going to fit into some of the specific problem domains that you have. But understanding where the platforms fit in your organization is the key to actually doing what you need to do. So let's talk about from an adoption point of view, right? One thing that we couldn't emphasize enough is this idea of product manager, the technical product manager, right? So the good news is that if you really look at, again, State of the Platform Engineering Report from 2024 and all that, you see that the success of the platform team has got a lot to do with having that technical product manager there. So this essentially means that people no longer believes that, hey, this is an investment that may not pay off. If I were to if I had to go out on a limb, I would say something like, the single most important role within a platform engineering team is that technical product manager role. If you don't have that, then anything that you build, again, it's not about a person, it's about that role. If you don't have that role, what you end up building may not be actually what would get used, and the whole initiative may not be successful. Talking about that cultural side of things, we have heard the statement, right? All of you have heard the statements is usually attributed to Peter Drucker. I don't know who said that, but culture is strategy for breakfast. So essentially, you can have all the best laid strategies and best tools and best approaches and all that. Eventually, it all comes down to one thing and one thing alone: the culture of your organization, right? And that is important as you really start thinking about ensuring that you have the right kind of solutions that you're building, but also ensure that that is going to stick and that is actually going to become the way in which your developers think. So platform engineering is moving fast, and the next wave is already here. Agentic platforms, domain-focused racks, embedded sustainability, cloud-native patterns. It just keeps going and going, right? So if this kind of content gets you thinking, and you want to stay on top of the industry shifts, subscribe to this channel and hit the bell icon so you never miss an update. We got more sessions for you coming, like implementing internal developer portals, cost-aware development platforms, and real-world adoption journeys from mid-sized to hybrid organizations. Stay informed, stay ahead, subscribe now, and let's explore this together. So, going into the next topic, let's think a little bit about what's next, what's coming up next, right? So this is the trough of disillusionment from the Gartner. You might have seen these ones in the past. So you can see that platform engineering is still in that space of peak of inflated expectations, right? Which means that the there's still a long way to go before you plateau out. So there is a lot of things that are happening within that space. And I've seen some reports recently, more, importantly, the DORA report from 2024, where I thought platform engineering is now moving into that next phase of trough of disillusionment, right? Where you're seeing that people are saying, oh, I use platform engineering, but my developers are not productive. It's not just that, it's the other way around. When I use platform engineering, my developers become less productive. So is that really true, right? It could be true, but the reason for that is some of the stuff that we already spoke about, which is like building things that your developers don't need, building things that you think are the right thing to do, but end of the day, developers didn't use it, right? Or developers are, you built all these things to reduce the cognitive load of your developers, but you ended up increasing that cognitive load. So when those kinds of things happen, you're definitely going to have a situation where the kind of studies from what you saw in DORA 2024 would be applicable. So let's be careful in trying to understand how to solve those problems. That doesn't mean that in platform engineering is dead and it's a concept that makes no sense. No, it does make sense. It continues to add value. It's a question of are you doing it the right way? And that is the single biggest question that you have to ask. So if we were to look at the predictions for the next 10 years, right? This is always a tough one to do, but at the same time, you can see some of the ideas that we have come up with. Needless to say, number one has to be the advent of Gen AI or agentic AI, right? I mean, so how is the platform engineering going to help? Not just from the point of view of building the capabilities, ensuring those kinds of capabilities are being used, but also from the point of view of how is platform engineering going to support more of this automated code generated ways of doing things, and how is that really going to help the whole process, right? Because it's not just about generating the code, it's also about building it and ensuring that you deliver it, the overall life cycle. That's where the engineering platforms would come in. And embedded platform engineering, we have been talking about Kubernetes operators and some of those operator patterns becoming advanced operators and all those things in the recent times. So definitely something that'll get a lot more attention in the near future. The platform convergence is something that we have been talking a lot more in the recent past, where you're starting to see a lot more of convergence around engineering platforms and the business platforms or the domain platforms and all that. So this is something that you'd expect to see a lot more activities in the near future. The convergence of portals and platforms. This is while this was actually being pushed off as like a sort of like a misnomer to start with, because both of the people refer to both of these things as IDPs. When somebody says IDP, nobody's entirely sure what they're talking about, because then they actually think of it as the same thing. It is not, right? So think of it like your portals as your front end and platforms as your back end or something. Again, highly simplistic way of looking at it, but you should start seeing a lot more convergence along these things, and which you probably already started seeing in the industry. I had, like when I did a previous version of this presentation, I had the green ops by default in platform engineering, meaning like any kind of decisions that you are really providing your developers to be more autonomous, ensures that you're doing the right decisions, the platform is making the right decisions for them. I've sort of struck that out partly in jest because of some of the things that's happening in the industry, especially in the US today, with some of the regulations and things like that. But in the long run, this is not really an option. We will all be forced to do that, irrespective of what language you talk when it comes to things like sustainability and all that. So this is something that for now I'm going to take a pause at it, but at the same time, so it's definitely something that won't go away for sure. A few other things is like, of course, the increase in serverless computing. We are continuing to see a lot more of those things. Then advanced orchestration, edge computing, and I wanted to specifically call out the agentic part of the platform engineering. And eventually, we are really going to talk about decentralized platforms, right? So essentially, that ensures those data integrity moving beyond PE and beyond the engineering platforms themselves. So, before we conclude, I wanted to talk a little bit about what will you learn from this book, right? So, since this is a book that you're going to read, we're not going to go into all the details. We'd love for you to read, but here are 10 things that you could learn from this book, right? So, number one, understand what platform engineering is and why it matters. There's a lot of literature out there that talks about various aspects of engineering platforms, but we don't think there is a book that has been attempted where you're giving that overview of everything that's in modern platform engineering. So essentially, this is something that you should read for that reason. We're also taking an approach of a domain, mental model within when you think about engineering platforms. So this is going to really solidify your understanding of engineering platforms from all the software foundations that you have had. So again, this is an attempt that we have never really seen before, which is why we attempted it. And collectively, the authors have close to 100 years of experience building things within the space. So we hope that you would enjoy that part. Third one, I touched upon a lot in this presentation, the whole idea of platforms as a product, right? So again, thinking of this as a product is thinking of engineering platforms as a product is the only way to do it. And we have lots of very interesting exercises and materials that will actually teach you how to do it. We are also using some real life case studies. We have obviously anonymized the company names and things like that, but we have a lot of so we have some fictional companies that we have used, fictional company names that we have used in the book that'll actually talk about what are those specific challenges that they encountered or the companies are encountering, how they solve it. I'm pretty sure one or more of these things would resonate with you guys. The other part of it is that this is not a theoretical book, right? This is not a book that tells you, okay, here is the thing that you would learn when you go to a classroom and learn this, right? I mean, so it is all about practice. This tells you how to build an engineering platform and takes you through the journey of building a platform, which is very important considering the fact that we actually defined that scope for it, right? So early on in this presentation, I talked about the scope of platform engineering. So this would be really good for you to know what actually goes into it, what should go into it, and what shouldn't go into it, kind of thing. Then there is a huge aspect of developer experience in it. So remember when we spoke about early on in this presentation, we said that developer experience requires platform engineering, right? And so now if somebody is asking you quickly, like, why are you doing this? You should be able to say, hey, I'm doing this because developer so-and-so told my technical product manager, this is a problem and this is a solution that they want to get to. So we are actually doing it to get there. So I think those kinds of examples would be there and be good for you to understand that. We are also definitely referring back to the team topologies book and the work, which we are, big fans of. And we are talking a lot about like, why does it matter and how do you actually extend that in the context of what we are trying to talk about. We have a separate chapter dedicated for observability in the context of engineering platforms. So it'll be good for you to really see how are we approaching that. So obviously, there are great observability books out there, and this is becoming the de facto industry standard going beyond the actual monitoring. So you'd actually find some of the things there to be interesting. We are also using some proven frameworks. We actually talked about a couple of frameworks here in this presentation about things like value modeling and all that. We are going into far more details and a lot of examples around how to actually use some of the frameworks. And we are definitely not forgetting about Gen AI because these days everybody needs to think about that, whatever software domain that they are operating in. So we are trying to future-proof a lot of the stuff that we talk about with Gen AI. And we know for a fact that these things could actually get obsoleted by the time we actually write or update this book the next time around. But at this point in time, in 2025, we want to make sure that we actually bring in whatever experience that we have had within that space. I mean, needless to say, we have had not much experience working with the Gen AI side of things or even agentic AI side of things, because that's fairly bleeding edge. But for whatever perspectives that we have, whatever opinions that we have on what's going to work and what's not going to work is going to be covered there. So sort of think of this like the 10 key points that you could take away from this book. So we'd encourage all of you to check it out and read the book. And if you need more information on the book, you can actually get it here. The MAPE is currently out, and the print version should be available in a month or two. So you should be able to get your print copy too if you are ready to buy the book right now. And for more information about the book, we would love for you to check out effectiveplatformengineering.com. So this is our book website that we keep updated all the time, so that you should be able to learn more from it as we move along. So thank you so much. We appreciate your time. And on behalf of all the authors, I hope this was an effective and useful presentation for you. So we look forward to you reading the book and giving us some feedback on it. Thank you so much.